In this video, we'll talk about semaphore. Semaphore is a class in java.util.concurrent package. Semaphores are generally used to restrict the number of threads to access resources. Semaphore basically maintain a set of permit through the use of counter. To access the resource, a thread must be granted a permit from the semaphore. If the counter is greater than 0, then access is allowed. If it is 0, then access is denied. If the semaphore count is greater than 0, then the thread acquires a permit, which causes the semaphore count to be decremented. Otherwise, a thread is blocked until a permit can be acquired. A thread releases the permit when the thread no longer needs an access to the shared resource and thereby increasing the counter. If a thread is waiting for the permit, it will acquire the permit and continue its execution. Example of semaphore: restricting number of connections to the database, bounding a collection. Now let's implement an example of semaphore in IntelliJ. So let's create a new example, and in this example what we'll be doing is that we'll be bounding a collection using semaphore. So we'll be creating a semaphore with 10 permits, and we'll be adding numbers to an array list, and we'll see that how we can bound adding to the array list by semaphore. So let's create an example, new, and then Java class, and the class name is bound collection. So let's first create a semaphore. We'll be creating a instance of semaphore, and that instance will be final because we don't need to reinitiate it. So private final semaphore and semaphore, and then private list of integer, and this list will be adding numbers to this list. Now let's create a constructor, public bound collection, and in this constructor we'll be setting up the limit with semaphore. So we'll be initiating semaphore with the limit. So first, semaphore is equal to new semaphore with the limit of 10, or with the limit 11. Now let's initiate our array list also. This dot array list is equal to, here we'll be using a synchronized array list. So what we'll be doing is that we'll be synchronizing array list using collections dot synchronize list and new array list. And this array list is of integer type. We'll be holding integer elements. So we'll be discussing more about synchronized list in our future section, but just think of this as a collection.synchronized list is the method which synchronizes list so that only one thread can operate inside this array list at one time. So this will block the modify operation on array list. So it realizes all the operations on array list. Now let's create add method, public boolean add and integer I, and here we'll be adding elements to our array list. So first of all, boolean added is equal to false. So we're creating a variable added is equal to false, and we'll be turning this flag to true once we are able to add the elements to the array list. Now we'll be getting the lock or permit using the semaphore.acquire. So it's complaining about the exception handling. So let's add exception to method signature. Now added is equal to array list dot add I. So array list dot add method returns a boolean. So once it is able to add this integer, it will return a boolean, and this boolean will become true. This added will become true. If not of added, then semaphore dot release. So if due to any reason it's unable to add this element to the array list, then release the semaphore. Return added. Now let's create a class. Let's create a method public remove, and this is also returning boolean. So here boolean removed is equal to array list dot remove. So if you are able to remove it from the array list, then boolean remove will become true. If removed, then semaphore dot release, and then return removed. Now let's create our public static void main method. So psvm, and inside our public static void main we'll be creating an instance of this class. We won't be modifying the instance of this class. So let's create a final, and bound collection is equal to new bound collection, and here we'll be providing a limit of 10. So we'll be creating semaphore with 10 permits. Now let's create 2 threads, and those 2 threads will be adding numbers to the array list from 1 to 20. A new thread start. Okay, we have this definition here, and then let's start one more thread. New thread. It's easier to generate the thread definition before start implementing, because there's a less chance that you will make mistakes. So that's why I always create the definition first and then start implementing inside the thread. So here I'll be looping from integer I is equal to 0, I is less than 20, and I plus plus. And I'll be calling the bound collection dot add. So I'm just adding this integer to the array list. Here is complaining about the exception handling. So let's surround with try catch. And once it is able to add, then I'll be printing out that it is added value with the thread.current thread.get name, thread.current thread.get name, and adding value plus I. Now let's implement the second thread, and the second thread will be doing the Same thing, but first what we'll do in this thread, because we don't want to initiate both of them at the same time, so I'll be sleeping this thread for like 1 second. Thread.sleep and 1 second. And then I'll be running a loop for integer I is equal to 0, I is less than 20, and I plus plus. If bound collection dot remove I, then print out, so thread dot current thread dot get name plus removing value plus I. And also here we just put if bound collection dot add, then print out. Complaining about the unhandled exception, let's add sound with try and catch. With this, our implementation is completed. Now let's look at the implementation. So we created two threads. First is adding numbers from integer I is equal to 0 to I is less than 10, and we are printing out adding value. And the second one is removing elements from the list, and we are printing out removing element. And in the add, we acquire a log, semaphore acquire a permit, and then after, if not a edit, then semaphore.release. And here in the remove, we are releasing the permit. So we acquire the permit in semaphore.acquire, and then afterwards in remove, if it able to remove it, then we are decreasing the semaphore count. So let's run this program. So you can see that here it's first adding values from 0 to 9, so there are 10 values, and then afterwards it will start removing those values and at the same time adding the values. So thread 0 adding values 10, removing value 0, so then afterwards it has to wait until the next thread remove the values, and once it's able to remove the values, then the other thread is able to add the values. So you can see that after the first 10 permit, thread has to wait until those elements are removed from those, so that, and the remove operation is the one who releases the permit.